Now moving on to the next topic. This is about centripetal force. What is meant by centripetal force? Or what is meant by centripetal acceleration? Look at this. I'm taking a circular motion. Circular motion. A body, this is called uniform circular motion. Uniform circular motion. What does it mean? The body is moving in a circle with constant speed. Okay, for example, the revolution of Earth around Sun. Correct. It is at constant speed, right? Every year, Earth takes how many days to complete one rotation? 365 days, right? Or will Earth run faster one particular year? No, never happens. Then, somebody was asking, what about the leap year? Leap year comes because every year is like 6 hours. Every year is like what? 365 days and 6 hours, around 6 hours. 5 hours, 21 minutes, 28 seconds. Okay, every year there will be like 5 additional hours. 4 hours to get 4 years together, that will be roughly 24 hours. That is how every leap year you're getting one extra day. It's not like Earth all of a sudden increases the speed. Got it? Earth moves at a constant speed. So constant speed, Earth revolves at a constant speed. That is called uniform circular motion. Or imagine you are running a race, 100-meter race. You are moving at a constant speed, right? Or the ceiling fan rotates at a constant speed, right? Okay, so this is such a circular motion. I'm drawing the speed. Look at this. Here the speed. I'm drawing the velocity here. Look at this. I'm drawing the velocity. Velocity is to the right. Velocity is straight up. Velocity is to the left. Velocity is down. So at any point, velocity is given by something called tangent. Yes, tangent. Okay, so here the speed is like 5 meters per second, 5 meters per second, 5 meters per second, 5 meters per second. Got it? Everywhere the speed is the same, right? Speed is the same. But think about this, everywhere the speed is the same. Velocity is different. Why? Velocity is a vector quantity. Correct. Look at this here. Velocity is what? 5 meters per second towards right. Here velocity is what? 5 meters per second upwards. Here velocity is what? 5 meters per second to the left. How about this one? 5 meters per second downwards. So look at this. In this case, I can say that the speed is constant. Speed is constant. Such a motion is called uniform circular motion. The more revolution of Earth around Sun, rotation of Earth on its axis, 24 hours, right? Earth takes 24 hours to complete one rotation, isn't it? Or revolution of Earth around Sun, or motion of a ceiling fan, or you're running around a circular track. These are all examples of uniform circular motion. Look at this. Here the speed is 5 meters per second, speed is 5 meters per second, speed is 5 meters per second, speed is 5 meters per second. But velocity is what? Velocity is different. Velocity is what? Velocity is a vector. Velocity is a vector. Vector has a direction. Correct. Vector changes when direction changes, right? So velocity keeps, tell me, velocity keeps changing. Velocity keeps changing. Who causes this direction change? Who causes this direction change? That little guy is called centripetal force. Centripetal acceleration, or rather centripetal acceleration. Centripetal means to the center. Centripetal means to the center. Okay, I'll write it somewhere here. There is a force called centripetal force, or there is an acceleration called centripetal acceleration. Why is it called centripetal acceleration? It is acting towards the center. It is acting towards the center right here, everywhere for that matter. Look at this. Centripetal acceleration is acting to the center. Centripetal acceleration is acting to the center everywhere. Look at this. Okay, everywhere the centripetal acceleration is acting to the center. All right. And this is essential for having a circular motion. So throughout class 11 and class 12, on many occasions, you'll come to hear about centripetal force or centripetal acceleration. Whenever you hear the word circular motion, you must think about centripetal force. Got it? Centripetal force is essential to have a circular motion. Where is centripetal force acting? It is acting towards the center. And centripetal acceleration has an equation. That equation is this. It is given by, you derive this in school classes, v square by r. V is the linear velocity, r is the radius. Linear velocity and r is the radius. V is the velocity, r is the radius. Or you can have an alternate equation, r omega square, where omega is, you might have learned in school classes, omega is 2 pi by t. Have you learned this? 2 pi by t, omega is equal to 2 pi by t. T is called the time period of revolution. Time period of revolution. Time taken to complete one revolution. Or this is also written as 2 pi into frequency. 1 by time period is also called frequency, the number of revolutions per second. For example, your car, they'll say in RPM, rotations per minute, revolutions per minute. They'll say like your car engine rotates, car engine's RPM is like 12,000. 12,000 RPM means the engine rotates 12,000 times in a minute. Got it? Or 200 times in a second. Got it? Anyway, this acceleration is called centripetal acceleration. There is a third equation, v omega. So this is in terms of velocity and radius. This is in terms of r and omega. And this one involves velocity and omega. So what will be centripetal force then? Centripetal force is given by F is equal to ma, right? So MAC, that will be equal to mv square by r. Okay, I'll just summarize it and I'll show you something. Look at this. Now we are talking about what? Uniform circular motion. Uniform circular motion. From the word uniform, you understand that the speed is constant. Got it? Speed is constant. It is moving at a constant speed. Constant speed. Got it? It doesn't change its speed. Got it? Speed is constant. Look at this, 5 meters per second, 5 meters per second, 5 meters per second, 5 meters per second. Even here, 5 meters per second, 5 meters per second, 5 meters per second, 5, 5, 5. Everywhere it is 5. But the direction keeps changing. Correct? Here it is to the right. Here it is up. Here it is to the left. And here it is down. Got it? And I can say that speed is constant here, but velocity keeps changing continuously. Why? Because the direction changes continuously. Who is responsible for this? There is a force called centripetal force or center seeking force. Okay, that force is always acting to the center. Got it? It's like a group of forces. Many forces can act as centripetal force. Okay, force is acting to the center. Okay, and while riding the bicycle, you tilt your cycle, right? You tilt your cycle a bit, right? You even some motorcycle racing, they even have a knee pad. The knee pad will touch the ground. They have to bend the motorcycle like this if they need to get enough centripetal force to take the curve. Got it? Or while taking off, the pilots do this. They tilt the plane, no? That's called banging of wings. The pilot always tilts the wings, okay, so that they can negotiate the curve. All right, otherwise the plane will crash. Got it? They have to take the loop with a banging for the wings. Got it? And there are many such occasions. Anyway, centripetal acceleration's equation is v square over r. V is velocity, r is the radius, or r into omega square. R is radius, omega is called angular velocity. What is angular velocity? You learned this in school classes. That is why I'm not taking it in detail. Omega is equal to 2 pi by t, where t is called the time period of revolution. Time taken to complete one circle. For example, Earth's time period of revolution is 365 days. Correct. Earth takes exactly 365 days to complete one revolution. What about time period of rotation? 24 hours, right? Correct. 1 day is 24 hours, right? Earth takes 24 hours to complete one rotation. Anyway, 1 by time period has another name that's also called frequency. Frequency is number of revolutions in a second. Got it? And I told you this is the equation for centripetal force, MAC, which is mv square by r. mv square by r. mv square by r. I simply put AC as v square by r. Or I can write m r omega square. I put r omega square. Or I can write it as mv omega. And I'll show you something. Look at this. This is like an example of centripetal force, which you might have seen already. Now, this was performed by Jaguar test drivers, stunt drivers. This is called looping the loop stunt, and the car is taking a complete loop. Even at the topmost point, the car wouldn't fall down. Why? Because even at the topmost point, the weight of the car would give the centripetal force to stay there itself. Look at the top of the loop. You expect the car to fall down at the top, right? But look at this. The car stays at the top, right? It doesn't fall down because even at the topmost point, the weight of the car should pull it down, but it doesn't happen. Why? Look at this. Even at the top, you expect the car to stop here, right? Fall down here. Look at this. The car's weight is acting to the center, right? Car's weight is always acting down, right? Gravity is down. Okay, gravity is down means to the center. That force is in fact the centripetal force. That is why it can stay there. Now, similar stunt was performed by Mercedes-Benz as well, and they actually did the stunt inside a tunnel, and the car actually went up the wall of the tunnel and did a 360-degree turn. The car even wouldn't fall down at the topmost point. Just see this. Did you see that? It actually completed a 360-degree turn inside the tunnel, right? It went up the wall and then completed. And the same thing you might have seen in death globe, right? Death globe. It is another thing, you might have seen in circus, right? Circus. Okay, they do this. Now, motorcyclists, they would circle inside a globe, right? At the top, you would expect them to fall down, but they wouldn't. Why? Because the weight will give the centripetal force. Weight will keep them in circular motion. If you maintain the speed, you can also ride this. Another demonstration of same centripetal force I'll show you. There are many of them, but anyway, I'll just show you one. Look at this. Now, this is another demonstration. Now, this is like wine taken in a glass, and then he is rotating the glass. Due to the centripetal force, the wine wouldn't fall down, wine wouldn't spill. See this? It's turning it upside down. Okay. It would still stay there, right? Because it is in circular motion, it has to stay there. Can't afford to fall down. Got it? Still stay there. Stays there. Okay. So that is the concept of centripetal force. Understood this, all of you? Everyone got it? Write this down, uniform circular motion. What is uniform circular motion again? Body moves with constant speed, right? So write this, speed is constant. Uniform circular motion means speed is constant. Speed is constant. Velocity keeps changing. Why does the velocity change? Because direction changes. Direction changes continuously, right? Because direction changes. Speed is constant. Throughout, it is say if it is 5, 5, 5, 5 everywhere, right? But velocity will keep changing as the direction keeps changing. Now, third point, write the momentum. That's a previous question. Momentum. P is equal to momentum you have learned, right? Mass into velocity. Correct? What about momentum? What do you think of momentum? Velocity is vector, right? Velocity is changing, right? Momentum is vector, right? So momentum also must change. Am I correct? Momentum keeps changing. I have seen this question in a couple of school papers as well. Okay. I said speed is constant. Speed does not change. But I said velocity is continuously changing. Why? Because the direction is changing. All right. And momentum also changes because momentum is mass into velocity, right? Then last one, kinetic energy. These 4 points are very important. Kinetic energy, half mv square. This v is in fact the magnitude. Put it in bracket. This v is in fact magnitude. Means without direction, right? So will it change? Does not change. I'll tell you one more time. Speed is a constant. Speed is magnitude alone. Speed is a constant. Correct. Speed is in fact the magnitude, the value. Do you understand? Speed is in fact the value alone, the magnitude. That is a constant. How about velocity? It changes because of the change in direction. Got it? Then how about momentum? Momentum would change because mass into velocity. Velocity changes, momentum also changes, isn't it? Then how about kinetic energy? Do not think that it is half into m into velocity square. It is in fact half into m into speed square. This is in fact speed, not velocity. Speed I know, speed is constant, right? If speed is constant, kinetic energy also is constant. And this leads to a very important 2 mark in class 12 board examination also. That's very, very important. All right. So these 4 points are very important. Even if in school it is not taken, you have to learn it. In school papers also, they'll ask us. Got it? Now we can write. Next point we can write. Who is responsible for this change in velocity? Centripetal force. Correct? Right. Centripetal force. Centripetal force is responsible for what? The change in velocity. That direction changes caused by centripetal force. Did you hear me? The direction change, that's happening because of centripetal force. Centripetal force meaning is what? Center seeking towards the center. Center seeking. The word meaning is center seeking. Centripetal force is responsible for the change in velocity. All of you understood until here? Right. Now we will write expression for centripetal acceleration. Write this. Centripetal acceleration is given by, write it. Centripetal acceleration is given by. Centripetal acceleration is given by. Hope you have learned this in school. That is why I'm not explaining it. Okay. You don't have time to derive it. That derivation is very important. 3 mark question. Centripetal acceleration is given by v square by r or r omega square or v omega. Put this in a box. We have one important equation. This is in fact one of the most important equations in first part of the reader. Centripetal acceleration is given by v square by r, or it is r omega square, or it is v omega. Why 3 equations? First equation has velocity and radius. Second equation involves radius and angular velocity. Third equation involves velocity and angular velocity. Got it. So let us also write centripetal force. Centripetal force. Centripetal force Fc is equal to MAC. That is mv square by r. That is equal to m r omega square. Is equal to mv omega. Put that also in a box. Centripetal force. And we will write what omega is and then wind up. Omega is called, I'll tell you more about this in the next session. We don't have time today. Angular velocity. Just like you have linear velocity, we have angular velocity in rotational motion. You've learned this already, angular velocity. Write the equation for angular velocity, 2 pi by time period. 2 pi by time period or 2 pi into F. Put this in a box. T is called what? T is called what? Time period, right? Time period of rotation. What is it in fact? Time taken to complete one revolution or time taken to complete one rotation. Frequency, you write. F is called frequency. In bracket, number of rotations or revolutions in 1 second. For example, if you look at the back side of your washing machine, you will see the RPM written there. Maybe they'll say like it is 6,000 RPM, which means the motor is running 6,000 times in a minute, completing 6,000 revolutions in 1 minute. Got it? That is called by the name frequency, and the reciprocal of time period is called frequency. 1 by time is called frequency. Understood everything we learned today? Shall we wind up for the day?